Welcome to section 9.7. 9.7 is dealing with a concept called the cross product. And so the cross product is a vector product that yields another vector. And so we weren't able to do this in 2 dimensions. It only works in 3 dimensions or higher. And so we're going to be dealing with this cross product, and they're going to show it all through 3-dimensional vectors. Sorry about that. So we're going to get another vector out of this. The key to getting this vector is to understand determinants of matrices, because that's the best way to organize it. So the determinant of a matrix. And so ideally we're reminding you of the determinant of a matrix. You could read about it in the book, but I'll try to briefly explain it. They're going to start out with maybe one like number 10, just to make sure you understand the determinant. So the determinant looks like this. So in number 10, they have a negative 4, 5, 0, 3 matrix. And our job is to take the determinant. How you take the determinant is you take a product of the diagonals. So as you go and you're sloping down to the right, those are all positive. So negative 4 times 3 is what we would do first. And then we're going to do a minus sign, right? Because we're going up the other way. 5 times 0. And so out of that, we're going to get a negative 12 minus 0 for negative 12. That's how you do matrices. So again, if it was A, B, C, D, it would be A times D minus B times C would be how that would work. So if we look at a 3-dimensional one, like number 14, they are giving us the letters A, B, C. And that's pretty wise that they're giving us letters across the top, because that's what we use in this cross product. And they give us numbers in this third row. So the way this works, if it's 3-dimensional, is you go across the top row. So the first thing that we see is this letter A. So we're going to take A, and we're going to take A times the determinant of what's under B and C. So we cross out A's column and row. And we cross out A's column and row, and we say, well, okay, then A is going to be multiplied by, and then we do this 2 by 2 determinant. Negative 2 times negative 2 minus 2 times negative 3. And that's what A is being multiplied by. So let me get in here and get an eraser and get rid of these dotted lines that I put in here pretty carefully. And now we're going to go over and get B. So with B, we're going to put a minus sign. Every time it's alternating signs. So it's A times this big mess minus B times its matrix. So its matrix would be crossing out its row and its column. Just do it off to the side. So we're going to look at what's left, these outside pieces here. And so we're going to take 1 times negative 2 and subtract away from that 0 times negative 3. And then we'll deal with C. So let me go in here and try to erase these dotted lines without messing up too much. Then we're going to go get C, and keep my eraser here for a minute. And then with C, we're going to cross out its row and column and take the determinant of what's left, this guy right here. And so it's going to be a plus because we alternate signs. So it's A minus B plus C, and then times C's determinant, which is 1 times 2 minus 0 times negative 2. And then we put it all together. So now if we look up in the first one, we have positive 4 minus a negative 6. So positive 4 plus 6 would be 10 A's. Over here we have a negative 2 coming out of the first bracket right here. Minus 0 is negative 2. The negative of negative 2b is positive 2b. And then here we have 1 times 2, which is 2, minus 0, which is still 2, times positive c is positive 2c. And so that's what they'll have when you look in the back for number 14. That's how we're going to find matrices, determinants of matrices, and that's really what allows us to find the cross product, as you'll see in the very next example.